So we're in Proteus now, and we have a schematic already set up, and we have some PCB layout already set up. This is actually the schematic of a student who was at Sheffield a while ago, and there are a few things that have been done well and a few things that are not as well as perhaps they could be done. So we can use it as an example of how to do a high-speed layout which is likely to work, or at least is not unlikely to work. So the student has quite competently set up some power supplies. You can see a 5 volt, 5 volt on the ground, and they've got a connector which is going to be a Molex style connector for their power input in the ground. They've got the op amp and they've got the JFET. They've not used the 2N3819, but it doesn't matter because the pin out of this one is the same. They've got decoupling here and decoupling on this rail as well. This is the positive and negative supply to the op amp, and that's good. They've got the capacitor composed of 3 capacitors that we talked about before. They've got the termination. The power splitter and all that other stuff is not actually on the circuit board, it's in the laboratory already. And the student has also made themselves a BNC connector device in the schematic capture and in the PCB layout as well. So this is fine. I mean, it's not the neatest in the world. I would probably lay it out a bit nicer, but it will do the job for this sort of circuit. If we go and look in the PCB layout now, there's not a bad attempt at the board, but there are a few things which often people trip up on. So first thing I'll probably do is go into the technology and set the textiles. The part value, the part reference, pardon me, I'll make it aerial. Something else which is easy to read and something that scales properly, I'll make it bigger as well. 0.1 inches I would have thought. That's better. You need to be able to see it properly on the silk. Don't forget, of course, that in situations where you've got pads, so let's see if I can find one. Not too bad actually. This is not going to be very clear. This you will not see. This line out here you will not see. There is a good chance that I'm using the wheel to zoom in there. C1, the 1 will be cut away because this via here will obstruct it, and they will cut the silk so that it can't go in that area. You can silk over tracks and you can silk anywhere else, but over vias and pads are purple, vias are yellowy, sort of mustard colour, it will take the silk away and you won't be able to see it. So we can see a few things have been done quite nicely. They've got 2 small capacitors here, C4 and C5, and these are low value ceramics, and this is to decouple the negative power supply of the op amp, which is pin 4, and then they've got the large electrolytic capacitors further away, and that's how you would do it normally. They have run most of their red tracks horizontally, and they've run most of their blue tracks vertically, except for a few down here. It's not a hard and fast rule, and there's no reason why you couldn't do blue horizontal, red vertical. It's usually a good way to lay out a board so you don't end up with tracks crossing each other. There's no ground plane on the board, and the layout there's a few little things that aren't quite right. For example, board companies really dislike it when you do this. You put a via on a pad because it's not difficult for them to produce it, but there is a chance that when you solder the capacitor in, you will upset or otherwise damage, unsolder, etc. the via. So they send you a board that they've tested electrically working in terms of continuity. You build it and find it doesn't work. Usually you ring them up and complain. So they prefer if you don't do that. They will probably ask you to move that. Other thing is there is no ground plane. You really want a ground plane on a high-speed board, so we'll do that. There's probably just about enough room between the BNC connector and this Molex. The Molex will stick out a bit, probably over the edge of the board, so we might move it in a bit. And the key thing is, well, we've got two vias there stacked on top of each other. Board company will not like that. This they will not like. If you look here, this is something that I find very distressing. This should be straight. The blue does not line up with the via. There's probably two vias, I think, there at least. This one don't line up. It's all a bit of a mess. There's no reason for that. It can be done properly. Other things slightly more worrying, the gap here is not big enough. I know that it says there are no design rule check errors, but that's because your design rules are not 10,000. 10,000 is probably okay. Still, I would not risk that. It's far too close. You're soldering this up yourself. Don't do it. So let's, oh yes, this J3, this would disappear completely. It's on the pad. Let's start off by trying to set up some components on the grid properly. There's no reason for the board to be this small, by the way. The student has just decided that's the case. So we take this minus, hang on a minute, -5 goes to the anode and ground is on the cathode. So this capacitor is in backwards. If we go and look at the schematic, sure enough, the cap's in backwards. Don't do that, it'll blow up. It'll blow up. So I double right click to get rid of it, then I select with the left click, use the plus key on the number pad, and I'll move it into position so I can actually see it. Then I'll auto route, no, not auto route, it will follow me to do the routing. While I'm here, turn that one round, pop it in there. You don't really need the word ground underneath. You can tell it to take that off somehow. See, it's not on this one, but it is on this one. Edit label, go away. There you go, done. Other two are non-polarized, so that's fine. That's okay. It's usual when you're doing this sort of thing to make this capacitor somewhere down here, and actually to take these away as well to make it look a bit cleaner. So what we can do, in fact, is move that one over a bit, move that one over a bit to there maybe. We might even, tell you what, we can do slightly differently, make it a bit better still. Usually put ground in the middle as well, because if you have short across here, there's a much bigger voltage. If we have short between the ground and one of the supplies, both supplies don't drop out, and we can usually tell which one has got the problem by looking at which supply is not working. So I'll move this one into the middle. Now I'll take this, a block copy, so I'll left click and drag to select just then. Block copy is this one. Put it down to here maybe, somewhere out of the way. Take this one, turn it around, minus on the bottom, usually the case. Take C6 and turn, oh, let's unconnect it first. I did Control Z then to undo it with a mistake. Drag that down there. Don't forget, of course, that it's the wrong way around again now. Put it the right way around. Click, 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 click. Ah, no, not that one. Move that up. We'll need a ground. Copy the ground from here. You can pull the ground from just there if you want to. That one there, that one there. That's the terminals and the ground. Power is here as well. And you can pull this one down as well. And we can try to put these in together properly. I'll probably move these as well. Then I can take this, turn it round, put on there. Same goes for these ones. Of course, the designer has to remember what they are decoupling with each capacitor. If you've got lots and lots of chips on a board, lots of ICs on a board, you'll need to remember what is supposed to decouple what, because they're all separate. But it's very commonly done. Pop that over there. You can hook them all up separately, you can hook them all up on the one. Doesn't matter. So C4 and C5 were supposed to be doing the pin 4. You can see tracking I've removed has gone greyed out, and it tells me change to pending. If I click this, it will delete the tracking that's gone. I'll retrack it. Mostly I will relay the board. So C4 and C5 for minus, this is -5, so I just probably how I would go about that one. This two. The purpose of the decoupling is to provide a good short circuit to ground for signals at the power supply of the op-amp. It's needed because the op-amp is expecting to draw current from effectively a Thevenin source with no internal resistance, and that's what we presume will happen when we switch on the circuit. Of course, to do that you need to store some energy up near the op-amp supply. Another way to think about the same thing is, let's imagine you're a signal and you're in the op-amp and you're trying to get to ground. You can either go out the output, so let's imagine I inject the signal in the output and I'm going to get the output resistance. 225, people will love this. Triple E 225, that is. You're travelling up towards the rail, you go in the rail, and then you've got to get to ground. If you have resistance and parasitic inductance in the power supply wiring, as you draw larger and smaller currents into the output stage, you will get varying voltage drops on the collector or the drain of the output push-pull pair, presuming it's a push-pull output. This may cause the collector or drain to wander below the base voltage, or at the very least it may also cause a set of conditions in the transistor where one of the impedances looking out of the base or the emitter, or rather looking into the base or emitter, appears negative, and of course then you make an oscillator. So you must decouple effectively. So this is how a decoupling will probably look, and this is how an input power supply will probably look. If you're looking at commercial schematics, there are usually quite a few sheets, even on a small design, and a lot of things are connected together by ports or labels. There's not usually a whole lot of actual wiring, because if there's analog then there is usually some, but if it's a big digital system, generally speaking, you've got a processor and a crystal and or an FPGA and a crystal or whatever, and the processor just sat there, and all its port pins have just got labels, and there's practically no actual wiring. It's much neater, and it's the common way. So we stripped out the decoupling, we stripped out the power supply, neaten that up. So I'm going to move this upwards now, probably to about there. I'll get rid of this because it's very ugly. This one has to come down a bit, that one can come down as well. This one I'm going to rotate into the usual position that we display it in. This, oops, that one comes up. I need a ground, that's my ground. Other thing I could probably do at this point if I want to make my life a bit easier is increase the grid spacing, because the grid spacing is quite dense. If you press F3 you get a sparser grid. F4 very sparse grid, it's too sparse. F3 is pretty good, so I can move things onto the grid just by clicking and dragging. It will snap them in for me. Don't need too much grid spacing, so yeah, they definitely line up now, and I'll delete that as well. This one can come in a bit closer. No reason for it to be out there. All this stuff can pop in as well. Is that lined up? That's not lined up very bad. The reason these aren't lining up is one of them has been dragged by its pin and the other has been dragged by its body. If you want to line it up, you've got to get rid of the wire for a bit. Take the thing and drag it by the pin onto the grid. This one, you see, now they line up. That's a consequence of having placed it on a grid and then changed it to a sparser grid. Lots of the problems that people experience, lots of the things that make the boards look a bit amateurish, are things which are to do with effectively attention to detail. There's a lot of pressure to get the board done, probably because the project is behind, because projects are inevitably always behind. If you need some proof, try Crossrail, HS2, any UK government project will be behind, I'm sure. Also, it's the same with student projects. The last PCB is a big rush at the end. So the care and detail goes out the window, and it's not a very, it's not as good as it could be. We'll move the termination in. I suppose if you really want to, you can bring this down here. I'm not going to, it's too far in my view. Bring in the BNC. We'll deal with how you make the BNC connector some other time. Bring this one across. Maybe drop it down one. Notice there's decoupling provided for this one and this one, but there's no decoupling provided for this one. Depends how far this is from that, or from down here, on the physical layout, how much distance there is, whether we decouple this separately or we can consider it to be decoupled by these ones already. This stuff we'll move up, pull that down there, or move it rather, pull the whole lot in, maybe not that far, that's quite close to that wire. It doesn't matter, it's just not so clear to read it. Bring this one up a bit, maybe bring this one up a bit. This is still pretty ugly, but it will do the job. That's probably how I'd leave it. Usually there is some title block and stuff down the bottom which says who signed it off and when and what project it's for, maybe what cost code is going to. This is in industry, of course. University we don't do that sort of thing unless it's a proper research project or it's industrial work. For student stuff it's just blank. Something like that will be fine. That's the sort of thing I would expect. Happy with that. I'll save that. File we saved in 8.14 format. This file cannot be loaded by older versions. Oh god, this is a travesty. Wonder why they changed the file format. You think they'd make it back compatible, really, wouldn't you? Oh hum. So we go and look at the board. There's quite a few things I've moved. There's a few things which now are not compliant. Well, these little rings are, it means there are problems with the design rule. Something is too close together, effectively. Very probably one of these vias too close to a pin. So if I do the changes pending, click, it will delete a lot of the tracking, some of the tracking. It doesn't solve all the problems for you. We need to lay it out. So down here I've got the x-axis, and over here I've got the y-axis. The origin at the moment is this thing here. There's a special word for what that is in typesetting, but I can't remember what it's called. Somebody will tell me, I'm sure. You can make a separate origin. So this is the master origin, and these things down here are black. They're the coordinates in thousandths of an inch. So I'm 1.980 inches to the right of the origin. Tells me that just below my cursor. Now I'm 2 inches to the right of the origin. So this big grids, that's 1 inch. So this board's pretty small. An inch, if you're not happy with the English system of units, I can't imagine why you would be, because they're not very practical. is 2.54 centimeters. So this board is about 5 centimeters long. Of course, you can zoom in practically until you can see the atoms. Doesn't mean you can actually build the board. So you've got to be careful with the layout package. You think you can build infinitely tiny things, and you can't. We need to leave enough room. So we can make a second origin. Let's suppose, for the sake of argument, I want to bring I don't know, this IC onto the grid. It's on the. Is it on the grid? I can just drag it a bit. It's not on the grid. You see, it snaps to the right a bit because the sides of each of the pads don't line up properly with each other. So it's not on grid at the moment, or at least that pad is not on grid. It may be that the person laid it out from the middle. Yeah, it looks that way because now it is on. It's on grid when I move it up and down. It depends on the package what's considered the origin of the package, and when you make the package, because this package was not made by the person, it already existed. But when you make a package yourself, you can tell Proteus where is the origin, and it will lay that down. So if I was to go into packages and pick out a 1206 chip resistor or capacitor and click that pad, that one there, that's where my mouse is at the moment, under that pad. This pad, the right hand pad, is nothing to do with the mouse, and it's not on the grid. There's no grid which lines up with the right hand pad in the same way the left hand pad does. When I touch down with a left mouse click, pin 1 of this package is on the grid. Pin 2 is not. My options for getting pin 2 on the grid, should I need it, are to move the origin to pin 2. The way I'll do that is I press O. That gives me a little character to suggest the origin is there. I can see, if I look, that the grid now lines up in the middle of the pad, and if I go down the bottom, I've got just here a number which is in purple, and just here another number in purple, and these are the distances, still in thousandths of an inch. It's what the th means at the end, from the middle of the pad 2, and everything else is now off grid, including pin 1. If I turn back to the main grid, everything goes black. You can see the grid shifted across if you missed it. There you go, totally different grids. The same spacing of grid, each miniature cell is the same width, but the origin is moved, it's translated effectively. Other thing I can do, if I'm content to use the main grid but I want pin 2 to be on the grid, I can drag it across a little bit. Oh, sorry, that box should not appear. It's because I double clicked by accident. So now pin 1 is off the grid. If you want both pins on the grid simultaneously, you need to find a grid spacing which is a multiple of the distance between them. Now, this package is measured in inches. This grid is in inches, so that's fine. But if, for example, you took an E-line transistor or MSOP, MSSOP package, they are laid out in millimeters, and you won't find a grid in inches that fits them. So you will have to, when you're putting down different components, switch probably not only between a grid and a translated version of the grid, but you probably also will have certain parts of your circuit board laid out with pitch spacings in millimeters, and certain parts of your circuit board laid out in pitch spacings in inches. It doesn't actually cause any problems as long as you're careful about deciding where your different grids are in use. It just takes a bit of practice, that's all. So I delete this now by right click and right click again. Difference between things that, difference in things I lay down like this doesn't have a name like J1 or C6 or whatever. This is not something which lives on my schematic. You can't go back to the schematic and there's something new appeared. It's not there. This is off the map, effectively. The difference, of course, is between the component mode and the packages mode. This is just packages that represent devices. It doesn't represent a specific example of a device. What lives in components, there's nothing at the moment because there's nothing here, but suppose I delete that. It goes back over there. I delete by double right clicking. J1 is there and it tells me the package is COM-SIL3, which is a connector and it's single in line, and there are 3 pins, which is what SIL3 is. I can rotate with a numeric plus minus. You can flip as well. I just drop it down there for now, it's not in the right spot. And you can see it's gone from over here, because this is a specific example of a Conceal 3 Molex, and that relates to J1 here. If I change the name, it will change the name over here as well. That's different from me going into the component, the packages bit and looking for Conceal 3. This one doesn't have, this is not J2 or not J anything, it's just a picture, which apparently I can't delete. There we go, it's because the grid spacing is a bit fine. Same way to change the grid as before. If I go F3, that's the grid we're on. F4 is a fatter grid. If I go F2, it looks really tiny, but if I zoom in, it goes even more tiny. So that's really small, and then a bit bigger. It's not drawing all the grids out. If you want crazy fine grid, Control F1. It's really small. We are now down in the 1 thou. 1 thou is about 15 microns. Let's just check that, shall we? It doesn't sound right to me. 1 over 1,000 times 25.4, which is the number of millimeters in an inch. And that's in millimeters. So if I multiply by 1,000, it'll be in microns. 25.4 microns. Should have done that in my head, really. So that's 25 microns. Now the width of a human hair is about 15 microns. And the size of some of the diodes that people use in fibre optic detectors is about 25 microns across. So we are down on the semiconductor device level here, but the package, software package, will allow you to lay out components at that level, and it will just presume that you have some magic or process by which you can manufacture them, the boards that is. And certainly at Sheffield we don't have the capacity to make circuit boards that level of precision, and if you try to order one from a board house, they will send it back to you. If you want to make semiconductors, fine, but we have other packages for design of semiconductor devices and other ways of doing the manufacturing. So try not to go too crazy with the grid, because it will let you do stuff that you can't do in the real world. Looking back at the overall picture now, I'll probably try to work out what needs to be decoupled and where the decoupling cap should go around the op amp. Then I'll start worrying about some of the bigger stuff, and then I'll think about how I'm going to track it. Usually if you're starting a board from scratch, you lay out most of the components and start tracking. What you'll probably find is either it all fits and there's big gaps, you've got no problem to lay out all your tracks, or in which case your components are a bit too widely spaced to start with, if you're worried about minimising the board area, that is. Or you'll find that you run out of space to track things and you need to make the components further apart, in which case they are a bit too close together to start with and your board needs to be a little bit bigger, or you need to choose more layers on your board. But more layers is not a silver bullet. Sometimes board area has to be increased, especially if you've got a lot of pins on your ICs. So next step, I'll start tidying effectively. There is no set rule, but we'll try and do a few bits of everything so you can see some examples. I'm going to put the op amp on the grid. This is going to be a local grid for the op amp, and it's going to be in inches. And if I look at pin 2 is on a line of the grid, so the pitch spacing is okay. This has to go. That's fine, nothing wrong with that really, but I don't like it that red and blue are both going downwards effectively. It should be one or the other. This needs work. We'll see about the decoupling. This is now the wrong way around because of some changes I made. So first thing I'll do is probably set the grid up as F3, and I'll double right click to delete the wire. Then I'll go into the component mode, grab this capacitor, change its orientation. I'm following the green rat. The green line's a rat's nest because they're the rat runs. A rat will run around its little home by the shortest route. If you ever had I don't know, a gerbil or guinea pig or some small rodent when you were a kid, and you kept them in a glass or a plastic container full of sawdust or hay or something, you can see the little runs they make, and they're quite cute. The green lines are like that, but they tell us the electrical connections we need to make. So I drag this now, and I'm dragging it by that pin there, this one, and I'm dragging on the grid. So pin 2 is now as close as I can get it to pin 4 of the op-amp chip, probably without the two of them touching. Actually, it's probably a little bit close. I might have to move it. If we go back to the schematic, we can see that C4 is 100 picofarad. The smaller the capacitor you're decoupling with, the closer it has to be to the thing you want to decouple. Big capacitors can be further away, they are just bulk energy storage effectively. Things to decouple your high frequencies have to be very close. The reason is, if I make this bit too far away, let's say I put it back here, and I go, that's okay, I'll just hook it up with the wire, doesn't matter. This wire, however short it may be, it's probably about, I don't know, 1.5 centimeters or so I should think, has some parasitic inductance. And roughly speaking, as a rule of thumb, you can imagine 1 nanohenry per centimetre. So you separated your decoupling capacitor from the thing it's supposed to decouple with an inductor which aims to make it hard for high frequencies to travel down the wire. That defeats the object of the decoupling. You must get them close. There's no way out of it. I didn't click it properly. There we go. So I'm going to pop it down there, and it's going to interfere with this wire, but I'm going to move that anyway. Then I've got this one here. This is going to be my 100 nano. 100 nano can be a little bit further away. Probably, I don't know what C8 and C9 are up to. Where do they come from? C8 and C9 over here. Oh right, okay, well. They should be somewhere over here. Okay, we'll get rid of them and we'll put them down later. I might get rid of some of this tracking as well, because it's I mean, what's going on there? Get rid of that, and that, and that, and that, and that. Yeah, there we go. And that one. No. A good rule of thumb for your tracking is, if it's a good Thevenin source that's driving a trace, track, same thing. Track is UK, trace often is American. If it's a good Thevenin source, a nice low output resistance, you can drive a long track, and that's okay. It's okay, you will drive the current through the track, and the resistance to the track shouldn't make too much difference. And if you get electromagnetic fields encountering your board, they will try to induce a current in any conducting loops that you find there, and a consequence of that is voltage will appear on that track, and the loop is made of the track and the ground effectively. So you'll get some voltage on that track, and that will impart some signal into your system which shouldn't be there, interference, which is the EMI, and this is bad news. If you've got very high impedance sources driving long tracks, it's easy for the current that flows in that loop to introduce a big voltage, because that current will flow through a big input or output impedance, and of course that will develop a big voltage. So you don't want your long tracks to be driven by high impedances. So if you've got high impedance nodes, keep all your tracks nice and short, and you keep your parasitic capacitance off that node low, because if you've got a big R and a little C, you've got a big time constant, and big time constants means low bandwidth, which is bad news. Or low slew rate, same difference. Not quite the same. One is large signal, one is small signal, but if we own 225, we know that. So we want to move Q1, probably doesn't really matter how close to the op-amp, because the op-amp is good at driving, but it's all in a big feedback network, and feedback networks need to be really short usually, because otherwise they tend to accumulate phase shift, and phase shift around feedback loop, if you're in 225, leads to oscillation, often. It's good if you want to make oscillator, but not so good if you want to make amplifier circuit. So we need to keep Q1 and U1 pretty close together. So let's carry on with C5 for a bit. We'll bring it down. That's one possibility. It's the wrong way around. Because I know that because the rats are crossed. You see that? So I'll try to make that way around. And you can see they don't line up. Now, if I was in a rush and I'd only been using Proteus for a couple of days, as opposed to about a decade, probably more than a decade actually, 1994, it used to be called CAD-Pack, and it was for DOS. It's great. And the whole thing fitted on a floppy disk. Anyway, yeah, I'd probably leave it like that, thinking, gosh, good enough. It really isn't. It hurts me to look at it. Makes me sad in my heart. Click the pin 2. Grab it. So now I depress the mouse button and I'm holding it, and then I gently move it to the left. You see it snaps in. The movement is tiny. That's perfect. That's how it should be. The question you've got to ask yourself in your head is, I'm going to pick these up with tweezers. Right, they're really small. If you want to know how big, I put metric by going M on the keyboard. Then I put the origin down on here and I move to this one. It's 3mm long. And that's 1 mil there. So it's under 2mm across and it's 3mm long, roughly speaking. You're going to have to pick it up with tweezers, and you're going to have to solder it with the tweezers too, because it will get really hot when you solder it. You won't be able to use your hands, burn you. Can I get a set of tweezers here and here? Because that's where I'm going to hold it when I solder it. I've got to be able to get the tweezers into this gap because I've put the next capacitor right there. So we have to be careful. How much space do you really need? I might be inclined actually to move this over, turn it around, grab it by pin 2, pop it up here. Now I don't want this on a metric grid, and when I'm working on the op-amp and all the stuff to do with the op-amp, I said I'd put my grid up here. So I'd go back and use that grid so that everything's on grid, and there's one grid for this little bit of the circuit. Then if I'm over here doing some other stuff, maybe it's metric, I have different grid. Only time the two grids have to be interfaced with each other is when I've got wires that go back and forth between them. So little bits like this, one grid, little bit over here, maybe another grid. To be honest, this board is so small, one grid is enough. I think we won't run into any troubles. That's okay. I would have thought, probably, just to be on the safe side, move it down one, move that over one. Yeah. The reason I want to be on the safe side is, let's imagine I make it. It takes 4 days to arrive if we're really lucky, and it took 3 days to get it ordered, so you're going to have to wait a week. If you've got it wrong, you're going to have to wait another week to get another one. If you're already stuck for time on your project, you're screwed. So you can afford a little bit more board area and slightly less good decoupling in order to build in a little bit of chance that it's going to work out first time. So I can track this now if I want to, but usually I will lay out more and then track a whole section or even the whole board. So let's go and delete this one. This is actually pretty good. This is fine. They all lined up nicely. Very happy with that. No problem. Quite close to pin 7, which is the thing we're trying to decouple. Yeah, that's good. We probably don't need this because I suspect these are ground actually. We will deal with ground plane in a bit. Yeah, they're ground. If I click it, all the stuff that's ground is highlighted. So actually pin 7 needs to be connected to these two. So really we want to turn these round. So I just grab them. I don't want this wire. There's nothing wrong with this wire, it's just in my way right now, so I'll get rid of it for a bit. Get rid of you as well. Just take these two. And I will rotate using the block rotate tool. Could I press plus? I could. Don't need to use the block rotate tool, but if you did, there it is. So they're misaligned now, so I just grab and drag it up a bit. pop it in the right place. C2, that can't stay there, we've got to be able to read that. So is C2 100 peak? C2 is the 100 peak, so that one should be the closer one, and C1 can be a little bit further away. Fine, no problem. So I might think about tracking that now. Let's deal with this, because this is another thing that drives me nuts about boards. Let's say I want to use this. I'm going to correct it and make it so I can use it, and I don't want to move that via. The via is good. Put the origin to the master origin, so down here my numbers have gone black, and I get the via over my mouse cursor and I'll press origin, and now I've got origin on the via. And you can see this 5-volt wire, sorry, that's the, move that out of the way. You can see the 5-volt wire, it's got a line in the middle that's on the origin. When I pull it, it moves, and as it moves you can see that the edge, upper edge of the track lines up with the grid wire, and it lines up with the next one and the next one. So it's on the grid, nothing to worry about there. Proteus is mad at me because I've connected two things together that I shouldn't have, because I dealt with this J1 earlier when I was buggering about. That makes things very inconvenient for my demonstration. Get rid of that. There. This is one of the things that Proteus annoys me about, but it doesn't matter. Can I actually continue this? Yes, I can. Good. So now I'm going to get this one, drag routes. I right click them, by the way, to get that menu, and I'm going to drag it up until it's on the grid. So now these two are lined up together. Awesome. But there's all this funny little, look at these crazy, what's this guy? I don't know. Drag that, I've got to pull that one in. What does that leave? Leaves one that's somewhere over here. You could either leave that or you could move it out. The way you might move it out, take that. This is the thing that I need to move. Click, drag it over on the grid, click, put it back on the grid. Done. Now it's beautiful. Now I know you can't see those sort of imperfections on a finished board, but they are there. And it's not excusable. It's easy to get it right if you put in a bit of effort and practice. As it happens, that V is not in the right place. I would like to put it about here. And because I'm going down, I'm going to take a blue wire. Blue is the bottom, the back of the board, and red is the top. This is not the only way. There are other ways to do it, but let's suppose I'm going to do it this way. If I double click now, it'll put a via and it'll put me on the red, which is the top side, and then I'll go right into pin 7. But as you can see from the white line, which goes between pin 7 and my cursor, mouse cursor, it's not going to line up straight. Let's watch what happens if I do it. Double click, got my via, and I move across and I put my cursor in the middle, which is not quite where the wire is. But if I click, it snaps it in for me, makes it look nice. And now this via is not on the grid. That's not the end of the world. If you wanted to put the via back on the grid, you'd have to have something wrong with the wiring, so that's how it is. Then I can wire up here. Technically this should be blue, but it's not going to be. Don't do that. What that does is it leaves you all this distance around here between the pin and the decoupling. That's no good. That one. These two only need connecting because they're ground. Do I really need to make this blue? Well, it depends. Ask yourself, am I ever going to put a red line through here for something? Because if I am, ignore that. Oh, there's a design rule error. Oh, now there's a design rule error there. So I can't even fit a red wire through there. So I may as well make this red wire. You could delete it. You have to relay this track. Bit of a nuisance. You could put a little red thing there. Delete that bit. Then run it up. That works out okay. And then go back and delete that. It's still a bit of a bad way of doing it. If I go back, what you could do is right click here, change layer, top copper, right click the via, because you don't need the via anymore, delete via, right click the via, delete via. Doesn't really matter how you deal with that, anyway it'll do. If I wanted a high-speed board, I'd probably do that as well. Oh, I missed it. Sorry, missed it. My bad. Try again. There we go. Don't get too close into pin 8 though. Pin 8 on this chip doesn't do anything, but it doesn't matter. Don't get too close. So that'll do for me. It's good enough. You could say, hang on, can't you just do that? Sure. You're cool. I'd probably do that, it's better. Sometimes when you're reading about layout, they will say, when you do your op amps, you always do this with your power supplies. And you run them really close together underneath like that, and you go all the, oops, sorry. You go all the way down your board and you stack up your op amps in a line like that, and it's great because you get a bit of capacitance between your power supplies, and that cancels out any common mode noise. Yep, that's true. But I've only got one op amp here, and I don't think it's going to be that big a deal. It's okay for me to lay out my power supply like this. It's not a crime. You could even do that instead. That's perfectly acceptable as well. I'll probably do that then in that case. That works. Anything like that will be fine. In this case, I think that one will do nicely. I may choose to move this later if I find that I need more room over here. I might move this one round and shuffle this down if I need more room up here. We'll see what happens. That's why you don't want to track too much of your board at once, because it's subject to change often as you go through it. That's why computers are very bad at laying out boards usually, despite the fact they have all sorts of clever algorithms to try and make the decisions. If you just ask it to auto-route a whole board, it will make a complete hash of it. The auto-routing is good when you've got, I don't know, a 32-line bus that needs routing through a gap half an inch wide to get to a FPGA or something which is on an angle, 45 degrees to everything else for some weird reason. If you just select that sort of square inch of board and get it to auto-route, it has a constrained problem. The problem is more to do with the mathematics of fitting that many wires through that space. The algorithms are very good at solving those sort of things. If you give the algorithm too much freedom, it has to start making choices based on the design. I know that C2 has to be close to U1's power supply pin because its job is decoupling. Now you can tell the algorithm what is power, what is signal, what is decoupling, all that. But for the sort of boards that we lay out in research, or undergraduate type stuff, we never get to a board that's so big that it's worth the effort for us to do it. And if you were laying out a motherboard for a PC, sure, you'll have a team of people laying it out most likely, and it'll be like a 24-layer board, and you will need to tell it all that stuff, and the auto-route will be doing a good chunk of the work probably. But then a human will have to sit there and pick through it to make sure it made all the right choices. Maybe edit it a bit. So for the sort of thing we're doing, no auto-routing. It won't make a good board. So I can carry on, I suppose. I'll probably move Q1 up. Probably turn it round as well, because pin 3 goes to pin 6. Get rid of this track. Grab that. Pick it up. I don't really want to go here, but let me move this over. There we go. That'll do. Do I need to decouple R1? Because R1 is just here on the +5. No, sorry, not R1, R4, my bad. Where's R4? R4 is over here. Oh, good lord, no. No. You come with me. You go away. Get this over here. Get these two pretty close together. This one is not very significant where it goes, so we can pop it over here. That's fine. Only thing we've got to be careful of is that we don't foul the connector. So this needs to get up to here really. This seems like it's a good candidate to move this down a bit. Maybe move this one in a bit. Got to decide how I'm going to get to pin 2 yet. Might think about turning it around. That little shift there was to get pin 3 on the grid. Okay, so that could probably be doing over there now. Could work. I've got to get pin 6 out somehow. Not necessarily too difficult. Best plan is probably to move this lot down. This is not the only way. There are a number of ways to do it. That's pretty ugly. Too close. Bit of a design change then. Have to move that down. Oops, not that. These. And the op amp. It didn't move the tracking just then, much to my annoyance, because I had component mode selected. If I'd done that with selection mode on, it would have moved the components and the tracking together. Show you. This is the point where I said I'm going to move it now. So let's move the tracking this time. Oh, can't stop selecting that cap, can I? Just shuffle it so that pin 1 is still on the grid, because that's what I would like it to be. Then I move these two, but I don't want to move that track, so I go back to component mode, pull these two in. Let's have another go. Oh, he's put this ugly little stubby bit in. There. I didn't get it close enough for the snapper to snap it where I wanted it. I should have been a bit more careful. Right, now I've got a bit more space over here. Awesome. So, pin 3 and pin 6, no problem. I'll track this now just so we can see it. But if I look at R4 and pin 1 of the JFAT, they're never going to line up because this isn't on the grid. I can put a new grid now. I press O twice to get the origin here. Grab pin 1, drag it, pull it. Now it's on the grid. These are on their own little private grid that only they're invited to. Go back to the main grid, then go back to this grid here. Doesn't really matter if pin 2 is on the grid or not. Now I've got two options. One is straight up, the other is down there. Neither is more attractive than the other really. There's There's not much point in trying to move R4 away from here. I would probably be inclined to do that and to add a decoupler here for it. That would be probably be my approach. So you would track that like that, and then this goes to the output, I think. Oh, it goes via a capacitor. So we'll need to get C4, which is output cap. No, it isn't. This R1 is a feedback. No, R4. Yeah, R4 is that one. So C7, C8, C9. C7. Where the hell is C7? I didn't delete it. It's here. What's it doing over there? Should be somewhere over here. Yeah, R2 and R3 need to be moved. Drop them down over there. This needs to go. That's a bit better. I'll line this one up with that one now, but of course you can't let the two of them foul each other. This is on its own grid, isn't it? So I've got to go back to the grid that I had for that and drop this on it. There we go. C3 must be a power supply thing, and then C6s as well. Depends how much space I might move that over eventually. I need to decouple down here as well. So the way I would do that is to just add these two in a bit. Drag that down. So C10, C11. Just deleted that extra junction. Since this is the one I'm interested in, I'll drop to there, and I can probably do something like this. This is not quite lined up. I was on pin 2 when I touched down on the grid, but it's pin 1 that I want to line up. You can see this rat is not quite straight. I click, click and hold, and drag it in, you'll see it snap. See that? Tiny little bit. Yeah. That's the one. I didn't need to put that track, it's just that Proteus didn't realise that they were actually connected because it still had a rat there. A rat line. So I just click again anyway, so that it knows. C11 is the 100 nan, C10 is the 100 peak. That we'll deal with in a bit. Is that feedback by any chance? R1 is the feedback. So feedback is going to go from pin 2 of the JFET via R1 to pin 2 of the op-amp. We want that pathway to be as short as possible. Now, this is the sort of situation where I'd be thinking about putting a component on the back of the board. Definitely, for this sort of thing. The way you do that is you get this one or that one, doesn't really matter. Grab it, change layer, solder side. So this is now going on the back of the board. Since we're looking through the top of the board onto the back face of the board, everything is mirrored in that y-axis. So X is flipped effectively. That's why the writing looks backwards now. And also scone blue. Now I can put this wherever I like. That would probably work out quite nicely. This is the virtual earth, so there's not much of an impedance there. This is driving the current through here. The impedance looking up there is probably 50, which is that R4. So I'll probably put this somewhere there. It's fine, doesn't really matter where. They don't line up. There's nothing you can do about that, it's just how it is. But you need vias. You can't put red on there, it will make you do blue. If you put red, it'll be on the wrong surface of the board. You probably can't get away with a via just there. It's probably too close to this pin. The via goes through the board, so I'm going to move that up a little bit, probably to there. Are we on the right grid? We're on the wrong grid. Oh, bad. Naughtiness. There, we're on the right grid. That's better. So now that one lines up. Ah, good. Thought that wasn't quite right. So what we can do is that. This is a bit frowned upon by board companies if they are putting the components on the board for you and wave soldering it, because sometimes you can find that these will collect a little bit of solder as the wave passes and end up shorting to something nearby. Probably not on this, which is like an SO8 package, but if you had a T-SOP or an M-SOP, something a bit smaller still, or BGA, they really get a bit upset about you putting these under chips or too close to chips. If the chip is really big, you put it right in the middle, it doesn't matter, but not too close to the pins. In this sort of situation, we're soldering this down ourselves. Don't worry about it. As long as you're confident you can do it without it bridging anything, no problem. So then I'll lay a blue one down here. You got options, but that's not that good because it's got to go around this angle. You don't want any sharp angles. No, that's not right. That's my preference. No, I trust I can solder that okay. So when you look at the 3D view, there it is. It's cute. We just laid out a component you can't see. This is the op amp. This is the JFET. That's the via onto the back face. That's the 50 ohm load. Look, R4 is chopped. Naughty. Must move that. This is my +5. Decoupling. Decoupling. Let's rotate. This is my component on the back. All on its own. So sad. It's the shortest possible path, I would have thought, from the op amp pin 2 to the JFET pin 2. Sometimes, if you can get away with not using a component on the back, it's good, because if the board house is putting the components on for you, it costs more money to have the components put on the back and the front, so obviously save money. Other problem is, it makes the design a bit more complicated to deal with, and you will introduce some parasitic inductance by putting in the vias. A certain length of track and a certain length of track with a via will have more inductance because of the via, and more parasitic capacitance as well. So if you can do your feedback on the top side, that's best. In this situation, because the way I've laid out the decoupling, and because it's not just pin 6 to pin 2, which it often is with op amps, it's not so easy, and I prefer this method. If pin 6 to pin 2, I just run a lead across there. Decouple down here, decouple up here, no problem. In this case, not quite so easy. Possible, but I choose this way. So pin 2's got something from R5 and a few other bits and pieces. I will finish the board and then I'll talk a bit more about it at the end, otherwise the video will be excessively long and very boring for you. I think the key elements I've dealt with: how to lay things on the grid, how the grids work, why the grids are the way they are, metric, imperial, how packaging roughly is done, how it relates to the schematic, what the rats mean, how to relay your tracks so they're neat, all that sort of thing. The only thing I didn't cover is power plane. So I've got this yellow bit around the outside, that's the board edge, and we go tools, power plane generator. You can see the auto router there, don't do it. Light auto scale, don't do it. Ground is power, put it on the bottom. Boundary will be T20. That deals with the distance between things. There's not much on the back, just this one, so I can see here. If I go into power plane mode, which is or zone mode, which is that one there, I can right click the plane, edit its properties, and I can determine the relief, which I'll make T20, and I'll determine the clearance, which is 20 as well. It just stops you from connecting things by accidentally soldering bits you shouldn't. There's a solder mask, of course, but that can be burned through if you have to rework several times. Everything else I pretty much leave as it is. You can see how it made all these bigger just then. Gives you a little bit more room for manoeuvre. Oops, sorry. If I go back into the 3D view, now you can see there's a power plane. You can see where the ground plane is not around the component. Right. Same for the top side. Tools, power plane generator, +5, no, ground. Always make your ground planes ground. T20, done. Now you can see on the edge the difference in the boundaries, so I can pick up the red one. If you're having a hard time picking up the red and the blue, especially if they're laying dead over each other, which they will in a bit, what you can do is force the selection on red by clicking that there. Now you can only select things on red. Filter the layer effectively. You can't select the blue one, doesn't matter how you try. Other possibility, if you don't fancy that, now I can select blue, no problem. You can go into view, edit what's visible, nothing, just want to see the red and the top silks. Now you can select the red freely. Maybe you want to also see the board edge. Right, now you can deal with it as well, no problem. So T20, solid, 20 thousandths, done. And it shuffled it in a bit. Then if we put everything back on, you'll see now they lay dead over each other, and choosing which one is not as easy as it might be. So I've got a bit more layout work to do, but it's getting there, and it'll be a nice looking single amplifier board with a current source output. So you could call it a transconductance amplifier if you wanted to, because that's the job it's doing. Right, I think that'll do for now.